Hello viewers, today my topic of the lecture is Scalars and Vectors. This lecture is equally good for O-level students and IGSC students who are planning to appear in the extended portion of the question paper. First of all is the definition of scalar quantity, and scalar quantities are those quantities which have magnitude or size only. Whereas if we have to define vector quantities, they'll be defined as in addition to magnitude and size, the vector quantities also have direction as well. The first example I have taken up is of distance and displacement. Distance is a scalar quantity and displacement is a vector quantity, and I have made a diagram in which I have taken a student going from his home to the school and coming back. In the blue path, the distance total has been shown as 10 kilometer. Can you see that the blue path has no specific direction? It is actually as you go from your home, the roads take turns around corners and in circular path, and you reach your school in the morning, and in the afternoon when the school is closed you come back and follow the same path. But there is no specific direction in this path. Your direction keeps changing, so this is distance. Whereas the green path is a straight line from home to school in eastward direction, and the distance, the length of the green path is 6.5 kilometer. When you return from your school, it is a red path, and it is again a straight line but in opposite direction of the green path. So 10 kilometer path has no direction, so it is a scalar quantity, whereas green and red are straight lines. You can say the shortest possible distance between your home and school and home. So they are having direction. From home to school it is eastward direction, and from school to home it is westward direction. Both are 6.5 kilometer. Now in vectors, if the eastward direction is taken as positive, then westward direction will be as negative. Having said that, then you need to remember at least 5 vector and 5 scalar quantities. I have listed them and I will read them out to you. Vector quantities are displacement, velocity, acceleration, force or weight, and momentum. Scalar quantities are distance, speed, mass, energy oblique work, and time. There are so many others, but these 5 are sufficient for you to remember. There are 2 more vectors to be remembered by the students who are going to take extended part of the paper, and they are electric field strength and the gravitational field strength. Now talking about the electric field strength, it is electric force per unit charge, and you already know from your knowledge of electric charges that there are forces between the electric charges. Like charges repel each other and unlike charges attract each other. This attraction and repulsion are forces between them. Whereas gravitational field strength is small g, your gravity, and it is gravitational force per unit mass. And gravitational force is also known as weight, so I have written small g is equal to W over m, the very famous formula for weight, whereas we say that W is equal to mg. Now there is a very interesting case of scalars and vectors in a circular motion, and that is that the body traveling in circular motion could be traveling distance, but its displacement will be 0, and that is when the body starts from point A and goes on to point B and comes back to A. Now, in doing so, the body would have covered a distance equal to 2 pi r, whereas since it has come back to the same point where from it started, its displacement will be 0. The distance will be covered when the body travels on the circumference of the circle, and displacement will be along the diameter of the circle. For example, I have written that if the radius of this circle is 7 meter, then if a body starts from A and goes to B on circular path, takes 10 seconds, let's say, then its distance covered will be 2 pi r divided by 2, which works out to be 22 meter, and its displacement will be to the left only 14 meter from A to B. So when we talk about distance and displacement, and time has already been given as 10 seconds, we can also find out the speed and the velocity. The speed will be distance over time. This will be called average speed, and it will be 2.2 meter per second, and velocity will be 1.4 meter per second to the left. Can you see? Distance has no direction and velocity has a direction towards the left while going from A to B. While dealing with vectors, we are required to find the combined effect of two vectors interacting with each other. That is also called finding the resultant of two vectors. The method used to do that is known as head-to-tail rule or tip-to-tail rule, and I have given in the diagram what is a tail and what is a head or a tip, shown in green color. Now vectors could be parallel vectors, they could be non-parallel vectors at an angle to each other, they could be perpendicular to each other, they could be opposite in direction. So we are going to discuss each case separately. Number one is same direction. I have made an object and placed two forces on it. Force is a vector quantity. Now in order to find the resultant of the two vectors, we are going to take first vector and label its tail as T1, head as H1, and then take vector 2 and label T2 and H2, then put them head to tail. In order to put them head to tail, we join the head of vector 1 with tail of vector 2 and we get a diagram as shown, and when we add them we get the resultant vector of force, which is equal to 5 Newton, and 5 Newton is obtained by adding the two vectors together. So this is a very simple method when the vectors are in same straight line and in the same direction. But when they are in opposite direction, again you have to put the head to tail method or tip to tail method. So I have done it, and I have drawn 7 Newton, shown its T1 and head 1, and then put the tail to 2 of 3 Newton vector, which is F2, on the head 1. Be very careful with the F force 2 vector, because for force 2 is in opposite direction to force 1, so its arrow will be pointing in opposite direction, and when we do that, the resultant vector, which is the green vector, it will start from T1 and go on to head 2, and then the addition of vectors will be done as 7 Newton plus bracket minus 3 Newton, and minus 3 Newton is because the 3 Newton is in the opposite direction of 7 Newton, both vectors, so 3 Newton is going to be subtracted, and the final resultant vector will appear to be as 4 Newton acting towards the right side. Two forces vectors F1 equal to 4 Newton, F2 equal to 12 Newton have been taken acting on a point O. F1 is acting at 30 degree to x-axis and F2 is acting at 15 degrees clockwise to x-axis. Now, graphical method to solve this vector problem and to find the resultant is as under. Step 1, you have to select a suitable scale. That is relation between the force and the length of the vector, newtons and centimeters. In this way, the vectors can be drawn in terms of centimeters on the paper, whereas newtons cannot be drawn directly on the paper. So the scale should be such that it fits in the page, it doesn't go out of the page. So in this case, I have selected a scale of 1 centimeter representing 2 Newton. Then your vector 1 or F1 works out to be 2 centimeter and F2 works out to be 6 centimeter. Then step 2 is to draw the vectors head to tail in given angles and directions. So you can watch the video in which I have drawn the head to tail. Okay, now I am drawing the reference axis, which is x-axis. So here is the x-axis and here is the point O from which the vectors are emerging. This one is point O. So I take F1, which is at 30 degrees to the x-axis. I have to draw the angle 30 degrees first. I'll take the protractor, place its origin on the O and place a dot here at 30 degree. When I got that dot 30 degree, then I will take the scale, and since this one F1 is for 2 centimeter, so I am going to draw a line of 2 centimeter in that direction. You got to have the pencil very sharp so that the lines are sharp and the results are good. So 2 centimeter in 30 degree direction is this. Here is that vector F1, okay, 2 centimeter, F1, 30 degrees, x-axis. This is the tail one, this is the head one. Now on head one again I have to draw x-axis parallel to this line, which is the reference axis. So I will take this as reference axis, and my line is almost parallel. Can you see this x-axis is passing through this line and it is parallel, and I'm going to draw the x-axis again here, very light line so that it doesn't disturb our main vectors. Main vector should be dark and the x-axis should be very light. So what I can do is that I can make it hashed lines because they are just reference axis. This seems to be a little out of parallel, so let me check. They are okay, right. And then second, when I have to draw the second vector, which is 15 degrees anti-clockwise, 15 degrees clockwise from the x-axis, I will draw that, and for that I am going to place the origin of the D on head 1 and make an angle of 15 degrees. This is the point which is going to make an angle of 15 degrees when joined with head 1. This angle is 15 degrees. I am going to recheck whether the angle is correct or not. Yes, it is correct. On this line, f2 is 6 centimeters, so I am going to take a length of 6 centimeters. Got to be very careful. The length should be correct and exactly on the same line. So this is 6 centimeters, this one here. So here is head 1 and the tail 2 and the head 2. Okay, head 2. Now all we have to do is join tail 1 with head 2. Tail 1 with head 2 to find the resultant. Here we go. This is the resultant. So its direction will be from tail 1 towards head 2 and we find out its length. Length is about 7.5. It is 7.5 centimeter. Resultant length is equal to 7.5 centimeter. Hence, resultant force. If the two vectors are at right angle to each other, then they can be solved by the help of Pythagoras theorem. And Pythagoras theorem you have to remember, that is hypotenuse square is equal to perpendicular square plus base square. And the direction of the resultant can be found out from the formula tangent theta is equal to perpendicular over base. The graphical method can also be applied to finding out the resultant vector of two vectors at 90 degrees to each other, which I will do after having done the Pythagoras theorem method. Now, first of all, we have to draw the vectors which have been given to us. In this case, there is a vector v1 30 meter per second going upwards or towards north, and vector 2 is velocity 2 25 meter per second to the right acting on a object at O. Now, step 1 is place the vectors in head to tail shape. So I have placed them in head to tail shape, taken v2 first, and then for v2 I have taken t2 and h2, and for v1 I have taken h1 and t1, and placed h2 and t1 together at one point, so they have become head to tail, and then joined the tail of v2 with head of v1, and the resultant is made in red color. Then applying the formula, Vr square is equal to V1 square plus V2 square. Vr is the resultant vector, putting in the values. Vr square is equal to 30 square plus 25 square, and finding out that Vr is equal to 39.05 meter per second. In order to find the direction of the resultant vector or velocity, apply the formula tangent theta is equal to P over B. From here we have theta is equal to tangent inverse P over B. So theta is equal to tangent inverse 30 over 25, and we find out that the resultant vector of velocity, which is 39 meter per second, is acting at 50 degrees to the x-axis. For graphical method, I am recording the video. Graphical method of finding resultant of two vectors perpendicular to each other. I am doing the step 2 now, because step 1 has been done on the previous page, in which scale and width has been selected. Step 2 is draw V1 equal to 6 centimeter vertical from O. So I take this to be O, and 6 centimeter from O vertical would be this thing from here to here, 6 centimeter, and here is the arrow. Then step 3 is draw V2 5 centimeter horizontal from O, and I draw this horizontal 5 centimeter from O without doing parallax error. So this is V1 6 centimeter, V2 5 centimeter, and then the compass steps. Step 4, take a compass, open 6 centimeter. Okay, this is 6 centimeter. Six centimeter. Put at the tip of V2 and draw an arc. Then open up 5 centimeter. The compass, 5 centimeter. Put it at the tip of V1 and get a point of intersection. And that point of intersection has been labeled as P, so I write down P here. Next step is step 5, and step 5 would be join the tips of both the vectors with P. So I am joining them. This is point P, and I joined that. Can you see that this vector is equal to V2, and when I join this, then this vector will be equal to V1. And if I go from O via V1 to P, this becomes head to tail. If I go from O via V2 to P, this also becomes head to tail. Then to obtain, and can you see this is now a parallelogram. And in order to find the resultant from first tail to last head from either side, and here is the resultant with double arrow. I can write this to be equal to VR, and right here join O with P to get the resultant vector or velocity. Step 6. Measure OP, multiply with scale to get magnitude of resultant velocity. So I am measuring OP, and OP is 7.7 centimeter. Page 6, the length of vector OP was 7.8 centimeter, and when we multiplied it with the scale, it came out to be 39 meter per second. In step 7, we have to measure angle theta with help of protractor or D at point O, and it is exactly 50 degrees. So we are quite happy with the answers. I would appreciate if you do this parallelogram method with this question at your home, and and see that the result is the same as we have done at tail method and scale method at page 4. Now we are at the end of the chapter of scalars and vectors. Kindly like and subscribe my channel. Thank you.